Hey, Gary. So we've been talking, and I really want to know, what is this thing EMI? What is this?
Okay, that's a good question. So EMI stands for electromagnetic interference, and every device that uses electricity, to boot up and operate, which is almost everything these days, emits an EMI emission or power fingerprint. So EMI basically refers to the interference caused by electromagnetic waves, basically energy waves. So EMI occurs when electromagnetic fields generated by devices next to one another affect the performance of other devices close to it or nearby to it. So the problem with EMI is that this can lead to various issues such as signal distortion, data loss, or even the malfunctioning of the equipment. So if you think about it, if you're operating in a mission critical network, say within healthcare, for example, right, the need to understand the effects of EMI and the impact of that business is very important for many reasons, because it affects the reliability and the security of the operation of the network and the devices running. And furthermore, because of the cost of software-defined radios have come down substantially from thousands of dollars to almost hundreds of dollars.
Sure.
Now, software-defined radios are really allowing EMI attacks to be pretty prolific, and they're significantly now on the increase. You've got attacks such as power hammer that is used to exfiltrate data through the power lines. You have attacks like XLED, which uses the LEDs on your routers, your network switches to exfiltrate data. You also have EMI attacks such as air jumper, which can be used to compromise the CCTVs over the EMI, exfiltration capabilities and so forth. So there's many attacks associated with EMI now, and again at LOCH, right? We're in this business of measuring this EMI power fingerprints from these devices, because we need to be able to detect any tampered hardware or counterfeit products that may in fact validate the supply chain source. So we are on the lookout for tampered hardware, counterfeit products as they're coming through the supply chain, as well as these layer 0 and EMI attacks.
So with all of these attacks and all the different things that are happening, what can be done to protect against these vulnerabilities that come inherently with EMI?
It's a good question. It's a great question, right? So EMI can introduce various vulnerabilities across electromagnetic systems and devices, especially in critical systems that I just mentioned above, right? Healthcare and so forth. And if they're using wireless to communicate and transmit data, a lot of these IoT protocols and frequencies that are now being used are going unmonitored. Not a lot of companies have the monitoring capabilities in place to look at the new frequencies and protocols that IoT is using. So therefore, a lot of these attacks are going unnoticed. And hence the reason for better understanding the impact of these EMI attack surface. And as I mentioned, right, there's a lot of attacks out there. They're leveraging these new vulnerabilities at layer 0, and things that EMI specifically will impact are things like data corruption, which is loss of data transmission. EMI can affect the malfunction of devices, whereby it can disrupt the normal operations or behavior of these devices, and ultimately leads to exploitation. EMI can affect interference in communications, whereby you have signal loss or signal degradation and so forth. So interference in communication is a big one. And also, just the general impact of these IoT devices
Mhm.
If they are, impacted by EMI, it will affect the protocol itself, and it will affect the ability to update them. So that's a huge
Mm.
problem. And one of the biggest impacts that I'm seeing within my customer base is that when they get compromised, the battery life on these IoT devices gets drained. So if you've rolled out, thousands or hundreds of thousands of IoT devices, and there's a malfunction in EMI, or there's an attack across EMI, and the battery has been reduced quite significantly, it means there's a lot of work in pulling them off the floor, the operations floor. So again, reduced battery is a huge problem with EMI as well. And of course, right, EMI is a new attack surface. Not a lot of
Mhm.
customers are aware of this, and it's creating new security risks, and it's allowing unauthorized access to the network and devices. As I mentioned, 2 or 3 attacks just a minute ago. Through the power supply, you can now jump from the airspace, the air, to EMI devices,
Mhm.
and that is one of the significant vulnerabilities customers should be aware of. And the net of it all is that customers have not implemented a power intrusion detection system to detect these new exposure states. So that's some of the risks associated with EMI, and
Right.
ultimately, EMI vulnerabilities can also lead to real health and safety concerns. If you think about it, right, our critical infrastructure, our operation technology environments that may be controlling water and power supplies and so forth could be affected by EMI attacks, and potentially endangering our citizens. So these are some of the attacks that risk of threats that EMI brings to the forefront.
All right, Gary, with all these threats and these vulnerabilities, kind of in anything that uses the electricity, which is pretty much everything in today's
Everything.
environment,
Yeah, exactly.
what can be done to protect against these things? I mean, that's a huge issue.
Yeah, again, another great question, right? So, protecting against EMI attacks is definitely a new area of concern for sure, especially as it relates to wireless. As I mentioned before, right, 80% of new devices are wirelessly connected these days. They're not wired, therefore wireless is the new network and new attack surface, etc. So minimizing the exposure state is crucial, especially in mission critical environments. So, in my opinion, in order to implement an effective defense in depth strategy to protect against EMI interference and attacks, customers should consider implementing a 24/7 monitoring system of their layer 0, 1, and 2 environment before an IP is ever assigned to any device.
Oh wow.
So before any device is even plugged in, as I was mentioning before, the ability to measure what should be against what is key, and therefore you're automatically reducing that attack surface
Mhm.
of EMI. So think about it, right? When any equipment comes into the environment, whether it be a router, a switch, a firewall, or a weapon, I'm thinking the DoD here, right?
Sure.
Everything comes with a motherboard these days. You should measure the EMI emission, the fingerprint, against a gold standard. That would be my recommendation. And of course, the goal here is very simple. It's to be able to identify any tampered hardware or counterfeit products before it's even plugged into the network. And there's been several cases already identified whereby foreign chips have been
Mhm.
found on motherboards, which have led to exploitation. And there was a great article a few years ago in the Bloomberg called "The Big Hack: which specifically addresses this concern. So it is happening. It is being infiltrated via supply chain, and hence the need, for this, ability to really understand what's going on with your equipment as they come into your environment.
Mhm.
So we need to start monitoring our EMI fingerprints to stay safe within our environment. I would also recommend that customers think about an EMI intrusion detection system. Right, there's nothing wrong with introducing an early warning system to measure the risks and measure the unusual activities that are going on at layer 0. This is where EMI lives, and then of course a lot of the attacks that are layer 1, and being able to have a good understanding of those risks, so that you're just protecting yourself. And then, again, being able to detect these nefarious wireless activities, right? So as things move from layer 0 to layer 1, they typically go to industrial Ethernet, and these are protocols that are non-traditional TCP/IP. But basically, being able to detect for these nefarious wireless communications that could be coming off these motherboards is critical, right? Because again, IoT is now cellular. It could be Bluetooth, it could be industrial Wi-Fi, and it could be leveraging the broad spectrum of IoT frequencies. And what's really interesting is a lot of organizations really understand about four operating systems: Windows, Linux. They understand a little bit of iOS and Android, and anything beyond that, including cellular and broad spectrum IoT, is kind of foreign to them. They don't really understand the risks and threats. So being able to have a good understanding of that attack surface is pretty important. And by the way, there are other solutions on the market, such as EMI shielding, that can be used to encase sensitive electronic components if you're completely, paranoid. There's other best practices you can do, like proper grounding, which allows you to kind of obviously insulate, specific, electronic components and so forth. You can also, use signal filtering to reduce the noise and isolate that traffic and so forth. And these are all additional, physical elements that you can implement to secure the EMI threat landscape. This is not necessarily an area that LOCH gets involved in, but customers could consider these alternatives.
Sure.
And that's really, EMI and risks and threats in a nutshell.
Well, great stuff, Garry. Thank you so much. And for for people that want to find out more about this, find out the solutions that LOCH offers, and how they can be protected against EMI threats, as well as a host of other things, wireless threats. Where can they find out more?
Yeah, please visit us at www.loch.io. That's LOCH.io. Thank you very much.